right. Well, thank you, Bex and CoreWeave, for having us. We're excited to be at Supercomputing 2023. We're Zeet. We're a CoreWeave partner. Today, we are sharing more about how to create a self-serve internal platform if you're doing Kubernetes, and CoreWeave is a great place to do your Kubernetes. So let's just talk about the topic of internal developer platforms. It's been a hot topic. Every organization wants to take advantage of cloud computing. Cloud computing has been around for a long time, yet still many teams struggle in terms of productivity and gains and being able to ship at the pace they want. So more recently, Cloud Native Computing Foundation, which is really the backer behind Kubernetes, has put a definition on what platforms are and essentially allowing and enabling organizations to capture the benefits of cloud and the ease that comes with cloud, and specifically building an internal platform, accelerating application and service delivery by the internal audience, the internal customers being particularly application developers. And so that's what we'll talk about. And kind of Johnny will go through and show a reference architecture on CoreWeave to how to make that happen, as well as show a demo of what it looks like from a developer and practitioner's perspective. Cool. And it's not a new thing. Global tech giants, they've been scaling their teams and their organizations and their roadmaps by providing internal tooling to their developers and to their internal users. And ultimately, what we're trying to do is give that same level of internal tooling that a developer at Facebook or Amazon has, give it to every type of organization from startup to mid-market to enterprises. And this is how Facebook can scale to shipping 100 million lines of code, and Amazon essentially has one deployment every second. And it really comes through internal tooling. That's what they're providing, and that's really what Zeet offers, and on top of CoreWeave and any cloud that you're using. And the outcomes that we're getting, so we've had many proof points with CoreWeave already. Chartio being one, a B2C audio. They're using AI. They're using 40 GPUs, and they're able to do that and manage 9 clusters with a pretty small team of backend engineers. And once they switch to this stack, including with CoreWeave's infrastructure, they improve their cost, they improve their latency, and where Zeet comes in is really improving the deployment part of it and adding productivity to the engineering team. So reducing the time it takes to bring that AI infrastructure up, and then everything it takes to operate it once you're live and survive production. All right, we're Zeet. I'm on the sales and business development side. I wanted to introduce Johnny, who's our founder and CEO. Johnny built these types of systems at AWS for internal engineers, and now we brought this company to market to help every organization have that same level of tooling. So Johnny, I'll hand it over to you. We'll go through a reference architecture and then followed by a demo.
Thank you, Sarfaraz. So as Sarfaraz said, I'm Johnny Dallas. I'm the co-founder and CEO of Zeet, and we build internal platforms on top of clouds. So this is a reference architecture that we're going to walk through today, built on top of CoreWeave for an example of an internal developer platform. So we're going to start with, there's 2 users or 2 different types of people that we're talking about in this architecture. First, we're going to talk about the user, the end user. How am I accessing this application once it's deployed? This is your user accessing it through a web browser or through whatever service you've got. But the second user we're going to talk about is the developer. Internal developer platforms are really for developers, people building the applications, people scaling the services. And we're going to talk a lot about how they can use a platform like Zeet alongside CoreWeave to facilitate more efficient operations. So we'll walk through a couple of the pieces here, and then I'll jump into a demo and show you actually this exact architecture deployed, and we'll hit on each of these pieces in a real-world capacity. To start, let's look at the CoreWeave account. So at the top, we've got this big CoreWeave account with a couple of different things deployed into it. First, we're going to start with the cluster components. These are pieces that Zeet, as the developer platform, is managing automatically for our customers. They're not necessarily having to develop a deep understanding of how each of these pieces work or manage them themselves, but they get all the benefits of them. There's a couple of pieces in here. First, we've got the traffic ingress. This is handling all of the networking and routing stack, everything from internal networks to public networks, handling load balancer configuration. Alongside that, we've got a managed Prometheus instance. This is a really critical part of developer platform of bringing the observability and monitoring. We'll see this shortly, but every single one of the projects that gets deployed to the customer deployment section over here is hooked into all of these components. So we're going to have Prometheus for everything, we're going to have traffic for everything, and we're going to have auto-scaling for everything. By putting these into cluster components that are just default on top of the CoreWeave cluster, we bring a bunch of new capabilities to application development teams that otherwise would not know how to properly leverage the Kubernetes API in front of them. As we look down here towards what is the main interface that the developers interact with, we'll look at the Zeet control plane. Now, in the Zeet control plane, there's a couple of different components, once again, that are bringing more advanced operations that a platform should have, or like Sarfaraz mentioned, some of the big companies, some of the big enterprises out there have these components, but you might not otherwise get to building on top of your own Kubernetes cluster. This is everything from the interface layer, the web dashboard, we also have an API and a CLI, how does the developer interact with the infrastructure, to a CI/CD controller. Every time there's new commits pushed to Git, how do we know the status of this? Which pod should it change? Is the build successful? What happens if the build fails? How do we communicate that back? We have an audit log built in for every single change that goes through the platform. It will be tracked in a central place with exactly who changed it, what changed, and when was that changed, which is really critical for recreating this infrastructure or debugging in the case of a downtime incident. You need to know who changed what when. And lastly, we have the rollout controller. This controls everything from zero downtime deploys to preview branch deployments. But generally, if I've got an application live, now how am I going to roll out changes to it? It's not just that day one, get a pod running. Actually maintaining a service at scale takes a lot of work. And the last piece of this is going to be a Docker Hub account where we have a container registry. We're using Docker Hub as our container registry here. We need some place to store all of the image artifacts and all of the built versions of our services. So this is the overall architecture we're going to build today. This platform gives users an easy way to access internal services and developers an easy way to control that infrastructure without having to become Kubernetes experts. So I'm now going to jump into a live demo of this architecture deployed on a Zeet and CoreWeave account together. So we'll give this 1 second. We'll see the architecture that we just described. So what you'll see here is the two services that we talked about as the customer deployments. Why? Because this is the interface for the developer. They care about two services. One, an external public API, and two, an internal, more secret API. Just on this page alone, there's a bunch of information that we can already get. I know that I have two services, but I can also see where these services are building from. This isn't just an infrastructure view where I can see a pod. I see this all the way tied into the GitHub repo. I can see when this was last touched. So it looks like our public API got touched during the last demo about 2 hours ago, and we can see that right here. I can see how to access these services, both publicly and privately. I think one detail that we had in the architecture diagram earlier, this secret internal API is not publicly accessible. We have a private network going between these services so that you can keep it more secure and optimize the networking. So I'm going to click into this Node Express demo project, and I'm going to show you some of those cluster components that we showed in the architecture before, and how, as a developer, I can modify this service now that it's live. Once I click into the project, the first thing that we're going to see is this overview page. This is going to be an overview of how is this service operating on my cluster. Bunch of the same information we're going to see as earlier, such as the GitHub repo, the endpoint that you can access this on, but a couple of more detailed, more helpful things, such as which exact commit is running right now, what are my real-time runtime logs? If I want to see this service, how is it actually handling traffic? I can see new log lines coming in here. I can click into this build section and see my build logs as they completed to create this commit, all in one place. And just the information that we have in this screen between build logs, the current status, the GitHub information, usually building a view like this takes combining multiple different APIs at different layers of the infrastructure stack to achieve this, and we've brought it to you in one simple place. Now, seeing what's going on is great. Everyone likes to know what's the current status of this, but we need to make some changes too. And so there's a couple of things that we have built in here to make the day two operations very simple. One piece is easy ability to debug these containers once they're live. So right up here in the right, you might see this terminal icon. This gives us the ability to, in real time, get into a replica of a production container and run some debugging commands. This is one of those features that you see as part of almost any production infrastructure stack, some version of a bastion host or some tunneling service to get access to production infrastructure. But we obfuscate the need to go and build all of that, figure out your own networking architecture by building it into the platform ourselves. We have this version live, and that's great. But a really critical part is going to be CI/CD. We mentioned that as one of the big components down here in the Zeet control plane earlier, that every time a new change comes out, there's new changes pushed to Git, we build those changes, we roll them out, and there's a zero downtime deploy that happens as part of that. So I'm going to click into the deployments tab here and show you just show you what that looks like. We're going to start with just one branch for right now. So we're going to click into this master branch, and we can see right here a full history of all of the rollouts that have occurred over time. You can see we had some changes go out a few hours ago as we were doing the last version of this demo. but we currently have a live deployed version and all the previous ones are stopped. What we'll do here is simulate what it looks like if a new developer pushes some code to this GitHub repository. When there's a new push, what we're going to do is we're going to kick off a new deployment, kick off a new build. We're going to build this fully in the customer's cluster. So this is actually a build occurring on the same CoreWeave Kubernetes cluster as a runtime environment, though properly segregated. Once this build completes, we're going to begin our rolling deploy. So what that means is the build will succeed. We will push the image to the Docker Hub container registry. We will pull that image onto the CoreWeave cluster. We will run health checks against that CoreWeave or that new pod. And if and only if all of those steps succeeded, will we move the load balancer over from the old version to the new version. This is one of those things that every developer platform should have. It's a modern standard practice of a DevOps system, zero downtime deploys and rolling deploys. It takes a lot of work to actually build that for your own system. And if you are early in the development lifecycle of building your own platform, you kind of want something like this that's going to bring it all together. So you can see here, our build succeeded. We ran some health checks, pulling the container right now. In just a few seconds, we're going to start running some health checks. And once those complete, we'll swap the load balancer over to the live version. Now, we can click into this deployment actually specifically and watch that process occur. In just a few seconds here, we'll start to see some new runtime logs showing up, and we'll have our load balancer live. Now, while we wait for that to happen, I'm going to jump into this revisions tab just for the sake of time and talk about one of the other big components of the Zeet control plane. We showed earlier audit log. I think this is an incredibly important part of any developer platform, is knowing who changed what, when, why. So here you can see every time that this project has been changed in configuration, we create a new record, a new snapshot of exactly what changed and who changed it. So you can see the entire state of the application at different moments in time, from how it was deployed initially to how it is being deployed right now. We've heard so many customers who will push out new changes on GitHub and they understand when that changes, but there's actually infrastructure level configuration that changes and causes downtime incidents, and there's no way to know exactly who changed what, when, why, whether it's changing environment variables or changing scaling settings. One of the other really important parts of having a developer platform like this is knowing what's going on with the service once it is deployed. So we mentioned earlier there's a managed Prometheus instance deployed into the cluster. Here on the metrics tab, we can show you some of the metrics that get pulled out of that Prometheus cluster. Here we can see CPU usage, memory usage, network usage, and disk usage all in one place. And again, all of this is very much intended for an application developer to be able to access it. I didn't have to write any PromQL queries. I didn't have to dig through any Grafana dashboards. I didn't have to do anything that really felt very infrastructure-y to get this information, which is incredible as an application developer that needs to know this information to do my job. Of course, if you are an infrastructure engineer and you want to dig into it, because the Prometheus cluster is in your own cloud, you can always click this View in Prometheus button and actually go and write your own queries on top of it yourself. What we've done here is provide a couple of defaults and just a quick exposing a couple of key metrics. There's a bunch of settings, and unfortunately, we won't have time to dig into all the things that a developer can do with a developer platform like Zeet on top of CoreWeave. So I'm going to skip through and just hit a couple of the highlights. What I'd like to spend some time on here is this resource and replication set page. This is one of the most important parts of actually managing a service on the day two. How big is the service? How many CPUs does it need? How many of them do I have right now? How do I scale it? How do I set up auto scaling? All of these questions are answered in this UI here. So you can see in this case, we've got this project deployed with a very simple preset, 1 CPU, 1 gig of RAM, and only 1 replica, no auto scaling turned on. But if I was an application developer and I realized, hey, my service is actually getting some load, this is pretty great, people want it, oh no, it's breaking, I need to scale it up, I can go into here and simply click on the auto scaling trigger and click save, and Zeet will automatically configure a horizontal pod autoscaler on your Kubernetes cluster and keep this application live according to these rules defined here. And this is defaulted to CPU, but we do also have memory utilization triggers, as well as more advanced custom Prometheus metrics queries. So if you want to autoscale off of something like disk usage or number of RPS or something more specific to your business, you can configure that as well. Again, ultimately, this is all about giving app developers easy access and easy control to the underlying infrastructure. Now, just for the sake of time, I'm going to show 2 other quick things. We spent a bunch of time here on this production API service that's public and available. But I do want to show you also the secret API service, which is only accessible internally. When you click into it, the big thing that you're going to notice at the start is there's no public endpoint, there's no visit button. We only have this private endpoint. If I jump here into the settings and we dig into the networking tab here on the left, we can see exactly where that's configured. I've told Zeet we have a server listening on port 3000. It should not be public. It does not need its own load balancer. It just should be exposed. And that's all I had to do to expose this within my cluster. There was no dealing with subnets, no dealing with sitter blocks, no dealing with IP ranges. By telling Zeet how all of these projects are supposed to work together, we can handle the translation into the Kubernetes terminology. The last thing I think I'll show you here is just how Zeet connects to CoreWeave. Obviously, we've got a CoreWeave audience here. But here on the Clouds tab, you can actually see exactly where Zeet and CoreWeave are connected. All it takes to connect a CoreWeave cluster is going into your CoreWeave account, grabbing your personal access token, and uploading to Zeet, and we'll establish this connection and create both a cloud and a cluster object in our database. You can see here, if I switch to the Clusters tab, all the details about what is currently being deployed. So all of these deployments have been going into a ORD1 region in CoreWeave using the Docker Hub registry. We've got these two projects, the public API and the secret API, deployed into that cluster. One value of Zeet is we are multi-cloud, and so if there were other clouds, you could move those projects around and define services that sit across multiple clouds. Today, we only have CoreWeave set up, but you can imagine AWS or other clouds alongside this here. So hopefully this has been helpful for you to understand what does a internal developer platform look like on top of CoreWeave. What are some of the things that developers are able to do on day one without having to go and become Kubernetes experts? Everything from monitoring to CI/CD to auto scaling to having this centralized dashboard, keeping track of all of your infrastructure resources and networking them together. Yeah, on the support side of things, so we have a couple of things. We have a built-in ticket center, so teams can use our built-in ticket center to page us or ask for architecture advice, or otherwise reach out to us, alongside a bunch of resources that we have available for everybody: our status page, our docs, our public roadmap, our help desk, and a couple of guides that we've put out. But additionally, we do private Slack Connect. It's a little hard to see on the screen, but we're happy to work with customers in their Slack channels, be a part of their team, work with them, and help them scale their infrastructure as effectively as possible.